Physics Engines and Physics in Games by Kıvılcım Çelik. What is a physics engine anyway? A physics engine is a piece of computer software that simulates physical systems like collision, gravity, fluid and solid dynamics, as well as more complex rigid body calculations, and more recently even soft body calculations. They're mostly used in games and film, as well as in dedicated physics simulators for scientific research. An even more advanced version of it would be the PPU, which is the Physics Processing Unit, which is basically a chip that is dedicated only for physics calculations. That's not really common, and more commonly is the general purpose processing on GPU, which I mentioned, the graphics processor unit processing capabilities for physics calculations, which is still the same thing, but instead of having a completely separate or independent chip, it just takes the physics load off the CPU and puts it onto the graphical processor unit. There are two main types of physics engines. The first one would be the scientific engine, and they're the oldest version of physics engines around. They date back to the mid-40s as one of the first computers, the ENIAC, or the Electronic Numerical Integrator in computer, was first accepted by the Army again in July 1946, and it was used to estimate artillery strike points, and it could take into account variables like weight and angles and even the wind strength at the point. Now, game engines, on the other hand, must run in real time because of the user interaction, so they're a lot simpler in terms of their physics rules, but that can also be related to artistic choices. Game engines have a few features that are usually common. The first one is gravity, which is one of the most common elements now. The second one would be the collision detection feature in games. And then there's rigid body dynamics, which is more complex. With the features, there also comes limitations. All games run physics engines real time. Precision and realism are limited to computational power at any given moment, so with lower processing power, the simulation may run lots of bugs, and if you increase the processing power required, you may not sell your product, so the producers must find ways to compromise both. With all the features I've counted, there are also lots of advancements that are being done lately in terms of physics engines. While physics methods in games have been limited to box-based rigid body physics for a long time, lately soft body physics, as well as completely different methods like volumetric tessellations, as in calculating volumes, or even continuous collision detection or digital molecular matter are now being implemented in games. Not only games, but also film now. A few of the common physics engines which are mostly used in the industry